Welcome to Maintenance of Traffic Training Part 3, Temporary Traffic Control Zones. When traffic is affected by construction, maintenance, or utility operations, traffic control is needed to safely guide and protect motorists, pedestrians, bicyclists, and workers in and through work zones. The traffic control zone is the area between the advance warning sign and the point beyond the work where traffic is no longer affected. Most traffic control zones can be divided into 4 areas. In this part of the training, we'll look at each of the areas and examine them for one direction of travel. If your work will affect more than one direction of travel, the same principles covered here will apply to traffic in all directions. The MUTCD describes 4 components of temporary traffic control zones: the advance warning area, the transition area, the activity area, and the termination area. Crashes can occur in all of these areas if they are not properly controlled. The advance warning area prepares drivers and alerts them as to what's coming. An advance warning area is necessary for all traffic control zones because drivers need to know what to expect. Before reaching the workspace, drivers should have enough time to adjust their driving patterns. In the advance warning area, traffic control devices may vary from a series of signs starting a mile or more in advance of the workspace to a single sign or flashing lights on a vehicle. The advance warning area from the first sign to the start of the transition area should be long enough to give the motorist enough time to respond to the traffic control devices. Next is the transition area. When work is performed within one or more travel lanes, a lane closure is generally required. In the transition area, traffic is channeled from the normal highway lanes to a new path, which is required to move traffic around the workspace. Most often, this is accomplished with tapers to close the lanes. The transition should be obvious to drivers. The correct path should be clearly marked with channelizing devices so the drivers will not make a mistake and follow the old path. If the existing pavement markings create confusion, temporary markings should be used. A taper is a series of channelizing devices placed at an angle to move traffic out of its normal path. Tapers are located either upstream or downstream of the workspace. The spacing for channelizing devices on tapers is based on several factors: the speed limit, the type of devices used such as cones, tubular markers, barricades, vertical panels or drums, and finally the location of the devices such as in the taper or the tangent. The taper length criteria for work zones can be found in Chapter 10 of the Plans Preparation Manual. The spacing of devices can be found in the Design Standards Index 600 series. There are 5 general types of tapers used in traffic control zones. It is important that you know what type of taper you will need and how to determine its length. Merging tapers close a lane of moving traffic on multi-lane highways where a merge is required. The length of the merging taper, which is used to close a lane, is determined by the speed of the traffic and the width of the lane to be closed. The formulas for determining the length of a merging taper are found in Index 613, Table 2. For a posted speed limit of 45 miles an hour and a lateral merge of 12 feet, you would need a taper of at least 540 feet, which is determined by the formula L equals WS. L is the length of the taper, W is the lane width, and S is the posted speed. For speeds 40 miles per hour or less, use the formula L equals WS squared divided by 60. Lane shift tapers move traffic to a different lane where a merge is not required. The taper length criteria for lane shift tapers can be found in Chapter 10 of the Plans Preparation Manual. A shoulder taper may be beneficial on a high-speed roadway where shoulders are part of the activity area and are closed, or when improved shoulders might be mistaken as a driving lane. When paved shoulders having a width of 8 feet or more are closed, use channelizing devices to close the shoulder in advance of the merging taper to direct vehicular traffic to remain within the travel way. Shoulder taper formulas can be found in the Design Standards Index 600 series. Two-way one-lane tapers control two-way traffic where drivers are required to alternately use a single lane. These tapers are used when flaggers are present. A short 50-foot taper is used to slow down traffic by giving the appearance of a restricted alignment. One or more flaggers or temporary traffic signals are used to assign the right-of-way in such conditions. The length of the taper is fixed at 50 feet as shown on Index 603. Channelizing devices are spaced a maximum of 20 feet to provide clear delineation of the taper. A closing taper is used at the downstream end of the work to allow drivers back into the lane that was closed. It's placed in the termination area. While closing tapers are optional, they may be useful in smoothing traffic flow. However, they may not be advisable when material trucks move into the workspace by backing up from the downstream end. If the closing taper is used, it should be 100 feet in length per lane. Let's briefly review tapers and taper lengths. Where traffic on a multi-lane highway must merge, the required length is a function of the speed limit and the lane width. When working on a shoulder, check Index 602 Table 2 to determine the required taper length. When traffic is on a two-way road and it is reduced to one lane, a 50-foot taper is needed. Downstream or termination area tapers are used to guide traffic back into the normal path. A 100-foot per lane taper may be used to let the driver know he may return to the closed portion of the roadway. If restricted sight distance is a problem, for example a sharp vertical or horizontal curve,